Okay, we are talking here about comparison tests, and one of the first tests we're going to look at is just direct comparison. Compare two series and just directly. And you might be asking, well, why would we want to do this? Well, the thing is that if you're trying to determine convergence, if you know something about one of the series, you can determine maybe convergence or divergence of the other. And so this very first test is actually one of the easiest, direct comparison, and it requires you know a little bit about the series that you're working with. So let's take a look at what it says. It says we've got two series, a sub n and b sub n, and they're both positive. They're greater than 0. And we're going to state the fact that the series a sub n is less than or equal to the series b sub n. All right, for all n equal to 1, 2, 3, so forth and so on. So what this tells us is that the sum of the series of A must be less than the sum of the series of B. All right? And it's actually probably better to say less than or equal to. But I think the important thing that we just want to note here is that this sum will be the smaller sum. Okay? So just kind of keep that in mind. All right? So let's think about what we know. It says in the first one, letter A, it says if the sum of the series B converges, then the sum of the series A must converge. Well, that should make some intuitive sense, because if B is the larger of the series, or the larger sum, I should say, and it converges, anything smaller than it must have to have converged. Okay? And similarly, if the smaller of the two series, in this case A, diverges, then the larger sum should also diverge. And that's what fact B is stating here. All right, so we're going to look at a few examples here. We're going to look at about 3 examples and kind of determine what we can say about this based on a comparison test. Well, looking at this first example, it says, does the sum of from 1 to infinity of 1 over 2 to the nth plus n converge? Well, they don't really give us anything to compare it to, but what we can do here is we can directly compare it to something that we know. All right, so let's go ahead and compare this one to something like 1 over 2 to the n. All right, 1 over 2 to the n is a good one that we can definitely compare with. All right, so when we compare those two, we're going to want to detail what these values are, and I think that'll make it helpful in determining which one is smaller and which one is larger. All right, so let's go ahead and take a look at that. All right, so what we're going to do is I'm going to list out these two series. The first one is n equal 1, all right, to infinity, of 1 over 2 to the nth plus n. That's the one we're given. All right, so let's think about those values. The first value is going to be, when you plug in 1, it's 2 to the first plus 1, so 1/3. Plus, let's plug in 2, 2 to the fourth is 4, plus 2 is 6, so 1/6. All right, and so forth and so on. So the next one would be like 1/11th and 1/20th and so forth and so on. Now we're going to compare it. Well, what are we going to compare it to? Well, let's take a look at 1 over 2 to the nth. All right, so we're going to look at that sum. All right, so we're going to go from 1 to infinity. All right, let's see what that looks like. 1 over to the nth. Well, let's see. That first value is going to give us 1/2. The second value is going to give us 1/4. All right, the third value is going to give us 1/8, and so forth and so on, right? Well, what can we say about this? All right, what can we say about this? Okay, well, if you think about it, really, 1 over 2 to the nth is actually bigger. All right, so I'm going to make that note that this one right here is bigger. All right, this is like your b sub n, and this one is your a sub n. So what can we say? If the larger of the two converges, then the smaller of the two converges, right? Well, let's think about this right here. R, what is the rate at which this is increasing? The common ratio. The R here is 1/2 every time. Well, what do we know about these kind of harmonic series? Well, if r equals 1/2 in a harmonic, I'm sorry, not harmonic series, geometric series, sorry. I'm jumping the gun here, talking about harmonics. We know that in a geometric series, if the common ratio is less than 1, the series then must converge. All right, so it converges. So if the bigger of the two here converges, then the smaller of the two must also converge. So this is our conclusion. All right, so I'm just going to make the statement here, and it's just a general statement, that the sum, all right, from 1 to infinity of 1 over to the nth plus n converges. And I'm going to say by comparison test or by direct comparison. All right. And that's the statement that we'll make, and that's our answer. All right, and I hope that makes sense right there. All right, I hope that definitely makes sense. If not, go back and view the beginning of this video, but let's go ahead and move on. Now we say we know that 1 over n squared plus 1 is between 0 and 1 over n squared. For any n greater than or equal to 1, it says using comparison test, what can we say about the summation from 1 over n squared plus 1, or the summation of 1 over n squared plus 1 from 1 to infinity? All right, so we know that we're going to have to establish something based on 1 over n squared, which is bigger. So let's consider that one, all right? And let me write that in blue just to stick with the convention here. We're going to be looking really at 1 over n squared, all right? And if we can base some fact on 1 over n squared, then we'll know the convergence or divergence of 1 over n squared plus 1. All right, so 1 over n squared here, this one is not a geometric series. I hope you remember what this one is. This is a p series. All right, so I'm going to tell you right off the bat, this converges. All right, this one does converge. Why? Because, like I said, it is a p series. All right, because it is a p series. And what do we know about p series from a previous video? Well, we know that if p, the power, is greater than 1, in this case p is 2, if the power p greater than 1, then we know that this series converges. All right, so our answer here, our conclusion, all right, since in this case, and I guess I need to highlight that for you, p equals 2, right? That's why this one converges, because p is greater than 1. P is actually 2. All right, so what can we say? Therefore, our conclusion is that the summation of from 1 to infinity of 1 over n squared plus 1 must also converge. Okay, it converges. All right, and that's because it's smaller than the 1 over n squared, which actually already converges because it is a p series with p equal to 2. And remember, for it to converge, p has to be greater than 1. All right, so a really nice example there, really straightforward, really basic. All right, nothing really to worry about there. All right, so let's go ahead and take a look at another example, and the last example of this variety. So it says, we know that n over n squared is in between n over n squared minus cosine squared of n and 0. Or 0, I should say, and n over n squared minus cosine squared. So n over n squared is right in between, all right? And it reduces, if you see here, as they tell you, to 1 over n for any n that's greater than or equal to 1. And it says use the comparison test, all right? What can we say about this summation, n equal 1 to infinity of n over n squared minus the cosine of n? Well, this one is actually really simple, but you got to remember something. This right here is a special case of the p series, 1 over n. All right, so I'm just going to go straight into writing my answer. And I'm going to say this right here diverges. This diverges. All right, Okay, why? This diverges because, as you can see, p equals 1, all right? In the summation from n equal 1 to infinity of 1 over n, all right, the power series. Now, in a previous video, we've discussed this before, and we said this was a very special case, all right, that diverges. All right, and why does it diverge? Well, in that previous video, we said that 1 over n, the special case, is what we call, I should say not a. It is exactly the harmonic series, and we know from that last video that a harmonic series diverges. All right, so n over n squared, which reduces to 1 over n, is actually less than the n over n squared minus cosine squared. If the smaller of the two diverges, then the larger of the two must also diverge. All right, so just kind of keep that in mind there. It must also diverge. All right, really nothing to it. Direct comparison, really nice, really easy. As always, I hope this video was helpful, and remember, like and subscribe.